and it'd be great to make good use of time. So happy to be back in the room with you all. I think maybe just to open things up, like if there's anything that you all want to share, like that you've had time to explore, or like any questions or roadblocks that you've come into. And then maybe third, like, are there some things that you're kind of thinking about making? Like, what do what would you take and make with this after this class? Or, even if it feels intimidating to launch into that, what kinds of things would be attractive and interesting to make as a, for a project that might come out of this?
I'll go. I have still been absorbing all of the material, but definitely I feel like it's interesting because I work in Python a lot and then do some modular stuff, so all the concepts are clicking with my brain, but just the language itself, like getting used to it. But I've been really interested in, I made like a simple, just cross modulation of two oscillators, and then in PCB rack, and plug my guitar into it, and then assigned an envelope follower to it so that I can kind of treat it as a distortion. And I'd really like to make that in here and then put it into a daisy patch and then code that, or I mean, just assign that to like some knobs for a pedal.
Cool. So cross modulation is like two oscillators that modulate each other's frequency? Is that what that is? Okay, cool.
Frequency, cross like frequency modulation.
Cool. And you're using that as a pedal?
So I use that, I made like a patch in PCB rack to do that. And then,
cool.
Put my guitar into it and then assigned an envelope follower from my guitar signal thing, and then combine those together. And so it kind of sounds like a weird, wild distortion. I guess like technically it's not. It's just like mixing a few things together.
Totally.
But it's a fun, random sound.
That's really interesting. Like that technique of like envelope following. That's actually very useful. I think to think about. Do people know what that is? So I guess I wonder if my microphone works on here. Does it work? Yeah, I think it works. So what you could do is something like you take an audio signal in, right? And this would be an audio signal. And you kind of want to, let me think about this. I think you could just use a slide, maybe. I would need to think about this because I think this is not what I want to do. But
if you said slide is a low pass filter, I think that like an envelope follower can be just a low pass filter.
Yeah, it looks like it. So now if I talk in here, then I'm getting this line that follows my voice. Oops, whoa. And what I could do is like this is going to be really well, we could do something like this. We could make some noise, and then we could use this signal here to modulate this noise, and we should maybe like, I don't know, put an amplifier on here too. And now let's see. Oh no. You type love into Max and that's kind of too good.
The plur objects.
The plur object's great. I mean, I've never used it, but it seems cool. Okay, so before I put this in the DAC, so this is not going to sound interesting, but you'll kind of be able to hear maybe a little bit. this kind of concept. Let's see. Do we hear it? Oh no, that's not what I want to do. What am I doing? So like this.
Out one with the noise.
Oh, it should be out 2. This is my bad. I'm just getting warmed up myself here. See, this is why I say about live coding with Jen. It can be a little tricky. But now we should be able to hear like some white noise that's modulated by my voice. So it kind of gets like stirred up. Something like this. And maybe we could say 0, slide up is 0, and instead of 10,000, maybe like 5,000, this will be like quick. And there is like a little latency. We could maybe go, you can hear like between my voice and the sound, there's like a little bit of a lag. We could go into our audio status and hopefully we could reduce this and maybe it's going to be quicker. Let's see, is it quicker? No. Why is it so laggy? It is really laggy. I mean, I think maybe it is probably the poor sound card on the computer, maybe. If you had like a nice audio interface or something like that, then you would be getting like a kind of synced overlay between my voice and this white noise. And of course, this white noise could be like you were talking about, this cross modulating thing. It could be the amplitude of some of these glitch patches. Maybe we could try that in a little bit. But yeah, anyway, that's really exciting and would be, pretty fun to implement. Cool. So we're just chatting about like what we encountered in the last couple of weeks, if we had time to look at stuff, like what came up, what the maybe big challenges and hurdles were, and then maybe also like if people are like kind of now dreaming about like this is what I could make or what I might like to make, just kind of chatting about that so we can kind of get it in the air and maybe inspire each other a bit. Anyone else thinking about anything?
I haven't absorbed much of the material yet. I tend to need to sit things for a while, but what I'm interested in making, and part of why I signed up for this, is a couple of years ago, actually more than that because it was COVID, but time collapses like that, made a project where I took images and took the RGB values and did some, made waves from those there was a whole concept, the whole thing, but it went, second by second. That was the time scale that we chose when we were using it, doing it. But being able to split that, like take an input, which is, turn something visual into numerical values, and splitting that more at the, the gen rate of 44.1 K, and what's possible there. I mean, bigger images for sure, but.
Yeah, no, that's interesting too. And I mean, I think maybe Paul, you should talk to Paul too.
If you're at all familiar with processing, you might find the library that I've been working on really interesting because it does exactly that. Lets you take any channel, RGB, HSB, combination of them, and turn it into audio data and vice versa. And it does this by mapping the audio signal along a path through the image that basically visits every single pixel.
Yeah.
So when you click in the image, you are in effect activating a location in the audio buffer.
Interesting, yeah.
And the type of curve you use then relates to some of the kinds of things that you can do by drawing on the image, for example.
Yeah, that's fascinating. Do you have this published anywhere?
Yeah, it's up on my GitHub page. I've been workshopping it now. I've done 2 workshops. I am very challenged. You say we can announce stuff?
Yeah, plugs.
I am doing a workshop in London, either in reality or in virtuality, for a conference in July on my piece of software.
Amazing.
For some reason, people say it might be cool. Bring it to us.
Cool. Fun. What's the conference?
It's EVA London, Electronic and Visual Arts London.
Fun. Nice.
Yeah.
That's amazing. It's really exciting. That's interesting too because the frame rate of video is obviously less than the frame rate, but what you could do. Oh no, I'm gonna get. Let's see, plane count 1 type. I forget how to use Gen, but let's do something like this, and then jet.window, is that what it's called? And then I think, don't I need like a metro or something? No, see, I messed up. It's not care, what is it? Maybe it's for. Yeah, anyway, I shouldn't try and do this without having for care. That looks right, doesn't it? We should see something. Maybe my video card is messed up or something like that. In any case, is it jit.noise? Anyway, if you look at this should work, right? Great, fine. So there's a lot of data here, you know, and so what you could think about doing is like, I think this is what you're thinking, but you could chunk this image, like every frame. This will come, this comes through, let's see, or is it UI, jit.ui. Frame rate. Okay, yeah, I should not try and do this live. The frame rate here is probably between 30 and 60 frames per second. And so if you're generating a big enough matrix here, you could, every sample, you could look at a different, like, sort of chunk of that. And that might be an interesting way to like think about that interface and like the time scale interface between the two. I'd be curious to see what you come up with.
Yeah, I'll look and share whatever I find.
Cool.
So yeah, one we did, it was like marching through pixels, and I had done it in Node, like wrote a whole script that would take the image apart, give you data for it, and then I think there's the Node.js like plugin or whatever it is for Max.
Oh yeah, for sure.
It's like it's Max 8, so I'm not sure how it is now, but that would give numbers, which would then go create these different waves, and there's like a look ahead, so there's an audio beating effect where it would kind of get distorted over time. If the numbers were too similar, they would get distorted.
Oh, interesting.
But like when you were speaking just now, it sounds like it's the other approach, right? Where rather than like going from image to numbers to sound, it's more, I don't know, it's more.
Well, it's really back and forth.
Yeah,
both of them.
exactly.
I mean, the idea was that they could be equal, they could be exchanging information, but you could also keep the resolution of the audio, keep the resolution of the image, treat the image as a signal because you've got a one-dimensional path through it, and like apply an FFT to both of them. Apply the same parameters, keep the low resolution that the image has, keep the high resolution comparatively that the audio has, and see what you come up with those things.
That'd be cool for working with live video too, right? Like, you know,
yeah,
it's like
and,
a webcam or whatever, you know.
The interesting thing about processing is it's really good for getting live video and pretty bad for getting live audio, except
That sounds right. Yeah.
Kind of disappointing, which is another reason why my project, since I'm talking, would be to sort of take things out of the library that I'm currently using, the Minim library for audio and processing, and instead use all the features that Max has.
Build it in Max.
For processing audio.
Cool.
And I already have UDP and potentially OSC communications set up between processing
Nice.
and Max.
Yeah, that seems really interesting. I mean, another thing to keep in mind too is you can build, you could build actually now with Rainbow, you could build any of this stuff out as a website that you could then put on the web and then go to, and then you could be, so like I tend to think about like how I know how this works on my machine, but I don't know how it's going to work on my student's machine or a collaborator's machine or whatever. And so like putting something on a website is kind of a nice way to streamline that. But you can also build standalone applications with Max, which might be handy too. Anybody else, like maybe one more thing that people are thinking about before we hop into some code stuff?
I have one more question, but maybe it will be resolved as we go along.
Do you have it? Yeah, the question might be helpful.
Well, these objects, the Gen DSP objects, I open them up in the patchers and I see that they're all full of little Max boxes that are linked together by lines, although I can't edit them.
that is like something in here that you're looking at. Is that right?
I think it was in, well, actually, since Freeverb is one of them.
Yeah, it's in the folder.
Ah, like here.
Right, down here, yeah. You open it up
Their version of
directly by
abstraction.
clicking on it, and you get textual code. You open
Yeah.
it up in the patcher, like you open up.
Like if I put it in here,
You
like
put it in a gen, and then double click on it. And
then
you
it
get-
opens up like this.
Oh.
Yeah. This is what you're talking about?
Yeah, and actually some of them just gave me all named objects with lines linking them.
Yeah. So this is also okay. What is this? So for people who write code, sometimes you write a function or something like that you want to reuse. This is similar to that. In Max, sometimes you write an abstraction. Like it's called making an abstraction. It's kind of like making your own object a little bit. But it's like freezing a max patch and then being able to reuse that. That's exactly what I've done here with like bandpass, for instance. So here's let's use this silly example here. And we're gonna say, let's call this a noise envelope follower, and maybe we're gonna get, we'll do something like slide down, we'll make min like 0 and max 10,000 or whatever, default, I don't know, 50, and there we go. So let's say this is like our perfect thing, and now what do we want to do? Let's imagine that we have a case where maybe what I want to do is I have like 8 channels of audio coming in, right? Okay, there's like a drum kit or something, and they all have different mics, or they're different contact mics on each of them. And I want each contact mic to trigger a different sound or a different process. So I don't just want one going in. What I could do is I could open this up here, and I could unlock it, and I could make many of these, right? And I could go back and I could change this, boom. Okay, that's 2, da-da-da-da-da. And then, this parameter is different, so I'm going to call this slide down 2. This is a mess. This is totally a mess. We don't want to do that. This is bad coding hygiene. What we want to do is we can go and hit save as. And we'll notice that when we hit save as, it doesn't say save a max patch. It says save as gen DSP. So I could call this on follower and save it here. And now what I could do is I could drop on follower here. And now I've just made my own operator, sort of, right? And if I open this up, it looks like this.
And that works in Gen, and the on follower works in Gen, even though it's like just what you currently have in Gen right now.
Exactly. So now it's like another instance of that. So what I could do, I said I wanted 8 audio channels. What I would really probably do is use the poly patch or use MC, but I could do this, right? And now each of these are unique. And so I could have 8 of these coming in, 8 channels coming in, 8 channels going out, and they would all sound sort of different. So maybe, yeah. Is this interesting? I could like,
Yeah.
Yes.
okay, all right. So then maybe I'll show something here. What I want to do then is I'm also going to say, let's use the slide down, but I'm also going to filter this noise, and I'm going to randomly select the frequency of the filter so that we have 8 different filtered noise that we can kind of differentiate between the two. So I'm going to use this band pass thing that I made, and I'm going to open this up. So this was also, again, like you can see bandpass.gen DSP. So input 1 is the signal, so I can hook up some noise to that, I think. 2 is the frequency, and 3 is the cue. So what I'm going to do is I want to randomize these values, like I said. I'm going to keep the cue the same, but let's randomize our frequency here. So what I'll do is I'll say noise. And this is where it can be like kind of this is a little bit annoying using gen. I sort of wish, I mean, I could make an object that does this, I suppose, or make an operator that does this, but I want to, when the patch loads, grab a value and scale that to be like within the frequency range that's interesting. So noise puts out between -1 and 1, and so I'm going to say, give me a value between 220 and 1600, something like that. Hello.
Hi.
So I'm going to sample this here. I'm going to output this here, like so. And then latch works in this way where it needs a 1 to grab that value. It needs anything that's not 0. So I'm going to say, look at how many samples have passed since load and reset. And if that number is less than 1, then this will be true, or it will send out a 1, and it will give us one number. And maybe what I want to do as well is I want to have a second input here, which, like, so that inside my patch I can also just hit a button and reset these. So I'm going to say, if this is either true, if this is true, like if it's the very first sample, or and this is the OR operator, then sample this noise and give us a frequency, and then that's going to be our noise value here, or filter our noise in a particular way. And this I'm going to hook up there. Okay, so now we have a patch where we have this random number generator between -1 and 1. We're looking to see how many samples. How many samples have passed? If it's less than 1, then let the noise through. It's kind of a gate. This is our OR operator here, these two vertical lines. Or if I send a 1 in from the outside, something like that. So all this to say, let's hear it. So we'll also notice some of these got updated and some of them didn't. This is actually kind of annoying.
Excuse me, is this just something that you're working on outside of the examples?
Yeah, that's right. We're trying to come up with, trying to show a little bit about saving gen patches to reuse them.
Okay.
So cool. So then we can go back and basically rebuild what we had before now. Let's make sure here, in 1, in 2, and then let's just go back here and send out, we'll just send out the audio. Okay. So again, just to rehearse this before we kind of zoom out of this zone here. Audio comes in. We have this envelope follower, which will look for peaks. It will, let's say, it will respond to peaks and smooth out decay. That's how it's set up right now. Then we use the amplitude of envelope follower basically how intense it is, to modulate the filtered noise. And then all this over here is generate a random frequency to filter noise. Maybe I'll make this a little bigger. Da, 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 da. Okay, I'm not going to spell check just because I want to go fast. Save. So now.
Wait, so slide just works as like a peak follower?
Exactly. That's how it's set up. So now when I make a new one of these, all those changes track, and that rules. Because now I don't, like, sometimes when you're doing Mac stuff, sometimes you do these subpatchers, you know, and like, you're like, oh, I'll just like copy and paste a subpatcher, but then the changes don't track. This is bad programming, like hygiene. This is the way to do this so that you can sort of make the edit once and it follows. We like that. This is also not the way I would do this, but oops, oh my God, oh no. Oh my God.
What the hell is that?
It's my Windows. Probably really wants to show you my Blade Runner screenshots or something like that. So I have this, okay. I would actually use Poly for this. I would use MC, but I'm gonna send here out one. I wonder if I could make this stereo. Maybe we can come back to that. We're not gonna make it stereo now. Yeah, actually, this is what I want to do. So I'm gonna actually, this will be my basic module.
Excuse me, envelope follower is that patch you were just working on?
Exactly. So we saved this as Gen DSP, and now I can reuse it. So I could just do something like this. And now I'm going to have hopefully a more complex tone. We're going to see. Oops. That doesn't matter. Does it? No, it doesn't. So I wonder what this sounds like. We're going to see what this sounds like. I hope it sounds interesting. It might not. Does it sound interesting? Test. Oh, my volume's down. Test, 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 test. Test. Not the most interesting. Let's see.
So all those out ones just get mixed?
Exactly. They get mixed down. Let's see if...
Is each source of noise then a different source of noise?
They're all different sources of noise, yeah. I wonder if I need to go back and change something. So it might be that... What could it be? I mean, actually, it doesn't sound totally uninteresting, but I would expect it to be a little more...
It sounds like it's mostly high frequency.
It does sound like that. I'm gonna adjust this and add like a Q in because I didn't have a Q before, so I wonder if that was doing something. A Q of 1, actually that seems like a lot, huh? Okay, well we'll try it. I'll turn the sound down.
What was that code box?
This was inside this bandpass object here. It's basically this is just a little bandpass filter. So a little bandpass filter.
So that's not a max construct.
It's
not a gen construct.
It is.
It is?
Yeah, but I made it just like I'm making this envelope follower.
Okay, so you made the code box.
Exactly. Yeah.
Okay.
So if I save this now, I don't know, to my desktop, envelope follower, synthy, maybe it will sound more interesting. Does it sound more interesting? No, it still sounds bad. Did this update correctly? So look, these didn't update. So this should have a 1 there, but it doesn't. So why is that? Did I save this? No, I didn't save this. So I'm going to save this. I'm going to close it. I'm going to close out of this. And then I'm going to do something which is to delete this, and then Control Z. And I'm wondering what this is. This is also...
Wow,
Yeah. It's so beautiful.
Wow, that's very nice of you to say. Thanks for saving me.
You don't want that kind of beauty in that spot.
These are the things that I usually bang my head against the wall for. But, okay, let's see. Does it sound any different? Probably not. No. Test.
That's different.
It sounds different. Is this here? Yeah, it is here. Actually, maybe we make the Q a smaller number. That actually might be. We go the other way. So I'm going to make this 0.1. Save. And probably I need to do the same thing, I reckon. And does it sound any different? Not really. I mean, I should just make these sine tones.
Yeah.
Let's do that. So instead of noise, I'm going to make these sine tones, which means I do want this, but I don't want this filter. I just want this to go directly into, so you can hear actually the other instances are still, whoa, modulated in that way. Boom. Oh, I wonder if that's why. I think I know what's happening. Okay. Whoa. Whoa. This is like a kind of, here, let me like not use my voice. Like tripping me out. What am I trying to do? So we should be able to hear some slight difference when I hit this click. Yeah. So it's kind of, I mean, it's like, this is a very poor resonant filter is what this is. But the point was not to make something super interesting. The point was to show this kind of way of abstracting and repeating, right? And having sort of like, now each one of these has its own distinct frequency. And that could be multiplied up as many times as you want, or scaled down, basically.
What did you said you would say this is a poly? What does that mean?
Okay, that we can look forward to.
Okay.
We can show this sort of poly. The other way to do this, are we gonna get into it now? Maybe I just show really quick. So one thing we could do, also, yeah, actually this is worth showing. So what I could do, here we have this special patch with many of them in there. But remember, I was just able to go and write ANV follower inside gen, and there it comes, like, because I saved it that way. I could also make a new gen patch or gen object and say on follower. And now it's in Max that it's doing this. So I could do then something like this, right? And then send this in here. And we'll hear just one tone. It's actually clearer. What we could also do is we could write mc.gen. Now this is a whole other thing, okay? But I'm just gonna show it to you, okay? mc.gen. And then I can hover over here and I can give it a number of channels. And I could say 20. and it should now have 20 channels coming out of here. Now, oh, what's happening? We don't hear it because this is... Okay, so what happened? Now we're talking about MC, sorry. What is this? What is this blue thing? I've never seen that.
The blue things indicate that it's a multi-channel signal cord.
Precisely. And so actually what's surprising here is it just says 1 coming out of here. I'm sort of surprised by that. I wonder
maybe
if...
because you instantiated it, directly, and so with 2 cables coming out, so it, you know what I mean? Kind of that, I don't know what I'm talking about.
No, that actually is interesting. That
Like
could be the...
if you redid it and...
Yes.
Yeah.
So now we see 20 channels coming out. Yeah.
Also, when you plug in a multi-channel signal object into something that only accepts a single channel signal object, it sums all of them together.
Sort of. We're actually only hearing 1 channel right now.
Oh, okay.
So we have to do a little bit more work again. So that's why we're like now doing.
Yeah, that's all you hear is 1 channel.
You only hear 1 channel, but I think that this. Yeah. Okay. Good. So what this does is it should turn this into a stereo signal for us, and it should auto mix it. Wait, is that right?
Yeah.
No.
Yeah, that's what I was
You gotta do like
thinking.
an unpack, I think, right?
I think that's right. Or there's also, okay, this is really, now we're now super doing MC, but there's MC.live.gain. And now we're going to see the stereo signal. This is also helpful. So if I show this here, we're going to see 20 of these, right? So that's all the channels coming out of here. Now this is mixed down to stereo, so I can go back and have my DAC. Da 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 da. Wait, is that right? Oh no. Mixed down. You're right. Sorry, we do need an unpack. MC.unpack.
Why do you need unpack?
So what unpack is going to do is take this blue cable and turn it into orange cables. So this is sort of normal audio, normal MSP.
Then it's a truly stereo again.
Exactly.
Yeah.
So this now too, I think that we also, is there MC Click? There's MC Click. That could be somebody's rap name. Okay, so this is how I would do this, because now when I open this, it's just that one, and I'm not looking at like 20 of those things over and over and over again, which is going to make me sick eventually if I want to do anything more complicated than what I just did, which is pretty simple. But now we have obviously like a more complicated tone, and I guess we do need to reset this. Oh, I wonder too, does this need to be like MC-ified?
I think that when you I'm trying to see, because I think that when you put in a single channel signal into a multi-channel object, it does just like copy that one signal across every single signal across every single channel.
Okay.
I'm looking at a patch that I have downloaded here where like it does exactly that.
I believe you. That sounds right, because we are seeing this sort of equal response across different channels here. So that tracks. Yeah, I mean, again, we could go and say, now I want, this is going to sound crazy, but like 120. It's not going to sound particularly good, but what we could do, if we wanted to, is we say, like, now we could go back. And this doesn't sound good because these frequencies have a totally arbitrary relationship to each other. But what we could say is 40, and it's going to be times a number between 1 and 20. 20. And we're going to round that down so that it's going to be like, it's not going to be 1.6, it's going to be 1. And what we're going to do then is then multiply that number by 40. And then we're going to have something that kind of sounds... I think we should probably square it. But anyway, this will sound kind of a little more ordered. Slightly more ordered, perhaps. Do I need to reinstantiate this? Maybe.
Save it.
I did save it. So you have like really strong, so in the harmonic series now you have really strong like ratio alignment because you're multiplying by like either, you have 40 times 1 which is 40, 40 times 2 which is 80, 40 times 3 which is 120 and so on. And so those kind of sound more cohesive to us, to the ear anyway.
Are you getting the incrementing number? Like the 1, 2, 3, multiplying by 40?
So before we were, from scale, exactly. So before we were taking this noise and multiplying it by like, to some range between 220 to 1600.
Right. So it's random, you're not incrementing in each patch or each instance.
Exactly.
So there's some duplicates probably. Like,
there are definitely duplicates.
Because that's what I was going to ask. This might be way off in another category, but can you do like arguments to each like instantiation of, okay.
You can
So
do.
in theory you could say I want frequency, for 40, I want like
Yes.
16. Yeah, okay.
Yeah, exactly. And then that's also something that I would probably write in Gen to go all the way back around. But that's another thing. But yeah, you can totally do that for sure.
Normally what I would do if I'm trying to figure out what's really going on, like what numbers are coming out of something, like coming out of that multiply box there.
Yeah, right.
See what's going in the cycle.
Let's
I
look.
would dump that out to an out.
Well,
But how do you handle that in an MC type situation?
great
How do you look at
question.
all-
So what we can do is we can open up, we go back to our Gen, we unlock, and I write out 2 or out whatever. And I'm gonna, so exactly, if we want to see what's coming out of here, we send it out 2, we save, and we don't see this out 2 yet. So I think what we could do, sometimes this works, this doesn't work. So I'm just gonna delete it and remake it, and there's our out. So now I could say mc.number, and now I would be able to see, actually if I hover over this, I see all these different values. And so those would be the various frequencies. Or I could use this display here, which is like kind of gross.
120 of those.
Oh, this is wrong. Yeah, exactly. Yeah, 120. Yeah, kind of hard to look at. But anyway, that is one way to do it. Is there like mc.print? I guess I don't want to even know that. This seems cursed. No, okay, mc.print doesn't exist. That's good. Okay, so this is like, that's totally another way to have many of one little thing. And like, that's a really, really helpful strategy for making complex tones. It's like, you have one little simple thing, and then you make many of them, and then you like think about the relationship between those things, and then you go. Okay, that's like the most broad sort of like advice in terms of sound composition. But okay, how are we doing? We got a little MC in. I promised a little MC, I think, in this class. We got a little MC.
Could use a little whiskey right now.
Little whiskey too, yeah. No, I wouldn't blame you. I'll save this and maybe throw it in the package or whatever, the project, so that people can look at that later. Yeah.
I had one question when you were calling upon env follower from within a gen object.
Mm-hmm.
How does it I forget exactly what it is, but I remember that env follower had a non-signal param inside of it.
Yes.
How does that if you're feeding the param from MaxMSP into gen, how does that work?
I don't know.
Okay.
I haven't figured that out yet.
Okay.
So I always I'm like, oh shit, I'm gonna like do this in multiples, and then I'll go back and rewrite it, basically. But there might be some way to do it that I just don't know. But yeah,
You're
indeed.
talking about passing params to each instance?
Yes.
Exactly.
Oh yeah, that's kind of what I was.
So there is so now I guess this is what's nice about what's it called, MC, is that this is the param that I wrote.
Oh,
and so
okay.
in MC it's exposed externally. So I could get a different result. This is in samples. This kind of sounds cool.
Now that sounds more like an envelope file.
Yeah. So now it's got a tail of a 40th of a second? No, that can't be right. This must be more than that. So then I re-randomize it. So then I could go back and say, like, here we have 40, but we're probably, you know, if this is going to be useful for us, we probably want this to be a different kind of tone. You know, we would want to be able to change this. So actually maybe what I would want to do is, we could do two things. All right, I'm going to take a little time with this because this is fun. I could make this a parameter, and I say minimum 20, max 1600, default 120. And now if I save, is this going to show up? I probably have to delete it. What's it called? Hertz? No, there it is. Right. So now you can have your, like, I don't know, crazy frog kind of thing. I don't know. But what is more interesting...
You gotta raise the frequency because right now the string keepers are out.
That's right. Probably what would be more interesting for people is, like, if you have your MIDI device or something, you could send this in. So I want to take these MIDI notes. I'm going to say MIDI to frequency. And then I think I have to send this in. We'll see if I have to send this in as... Right, something like this. So now you have, like, you're kind of sampling this drum kit here, which, by the way, like, now we could go and use a different sample and it's going to sound really different. It'll have a different rhythm embedded into it. I don't know.
Don't you have, like, trains crashing or anything?
I think at one point in my life I certainly did. I admit that my audio library on here is not that impressive. Funky. Let's do funky. And I could just combine these, actually. That might be interesting, but... Right, so now there's another rhythm embedded in here, right? You could have it sort of changing notes, something like that.
What is that inlet 3?
So inlet 3 is now taking a frequency value in, some frequency. Whoa. Que paso? Oh, that's interesting. It just reverted to that old... We just went back in time. Whoa, we're stuck in time, y'all. Why would that happen? Well,
there are gremlins.
Yeah, there are gremlins.
Also, before in time, was that a float chord going into a gen object?
It was, yeah, and I know I said you can't do that, but I think actually you can.
Oh.
I just learned.
Is it just like bad coding habits?
I think like nobody is gonna get upset with you, but I like to do this thing and think like and live in a world where I imagine only signal can go in there.
Well, is it because it's MC actually? Maybe.
No, Jen should or Jen will take it. I mean, I wonder if it. Well,
why would Jen disallow a float?
I thought that. Yeah, I thought that it only dealt with signals.
Because what?
I thought that it only dealt with signals. It only put signals out. That's for sure. We know that.
Well, float
Within
going
the
into a
gen-
SIG is a signal, right?
What's that?
If you put float into a SIG,
Yeah.
then you've got a signal.
Then you got a signal. Exactly.
What you're saying, you just didn't know if it would work without the SIG.
That's right. Yeah. I thought that it didn't, but it does. So I was probably doing something wrong when I was learning this, and then that got stuck in my head, and then I just showed it to you all right now. I just showed you my whole ass.
We'll give you a trepanation after the
That sounds fine. Okay, any other questions about this?
Yeah, save it so we can look at this shit later.
Cool. Happy to.
I guess I'm still not wondering if so now you're sending obviously like you're sending that value 73.416 etc. into every instance, right?
Correct.
Is there a way to send like 4 different values
Targeted.
Yeah, that's kind of more what I was wondering before.
So this isn't.
Use MC.
You do MC pack.
I want more tables and more things doing more.
Totally.
More ring mud.
So if we say there are 4 channels only, like we'll. Kind of sounds sick.
Yeah, I like that.
So what I could do is I could say, this is going to be kind of a gross way to do this. But what I could say is, so you'll hear now this become more and more sort of filtered. What is that, D? Or at least you should, if this is working the way I think it does. DA. So you could have like different tones for these different instances now. I
Doesn't
think.
sound right.
Does it have to go into an unpack?
It shouldn't. Yeah, we're not really hearing this one.
No.
Oh, you are.
Got one.
I don't know why this wouldn't work. That's weird.
Every other one.
Oh, is it like a stereo thing?
Right, like add some rhythms.
This looks like they are coming through, right? Yeah. I don't know. That's surprising.
How does it know to deal with that multi-channel stream coming into link 3?
So it just knows that this is, because this is MC.gen.
Yeah.
It's going to expect this MC cable to come in.
Wait. What is MC? What's going into MC.mixdown right now? It's just to the left of the screen.
Oh, actually, that's a good point. Well,
Huh?
so yeah, that is four discrete channels that are different. So what Mixdown does is it sort of mixes a multi-channel thing down into stereo or into whatever number of channels you might want. So this is helpful for.
Well, what happened to outlet 2 that we could look at numbers?
Right here.
Yeah.
Well, it depends what numbers we want to look at. I guess we could look at. Yeah, this should be sending something out, eh?
I mean, that would
Good point.
reflect what's going on with those keyboards, right?
It should. Let's check it out. Good point.
You know what? You gotta debug this shit as you go along. Otherwise, you keep going in a wrong turn and wrong forest. Before you know it, there's bear shit right in the
So these are also not values that I would expect, which
Exactly.
is strange.
See?
It's a good point.
Higher frequency than you'd expect.
Yeah, this is. Oh, but
They're being multiplied, okay?
they're being multiplied by an arbitrary value. Okay, that's why. Okay, hold on. So let me.
Yeah, because you're going from 1 to 20
Yeah,
and then multiplying by all that stuff.
I forgot what I coded. So I can just go and do this now.
Yeah, you don't need that other crap.
So now. So here's A, and we'll do E, and then C, and then below D. Yeah, something like that.
That makes more sense.
Is this an amazing thing that you want to show other people? It might be the start of something. I don't know. I just made it in 20 minutes with you all, so we made it together. Yeah, that was good to think through, actually. I hope that was interesting for others. Why don't we take a pause at 7 here, take a breather, get some water, get some air. We'll come back in, let's say 5 minutes, and we'll get into some of the examples from this week. Seem good? Cool. Thanks, folks. We got a chance to look at them. I brought some books. We can do it like this. So this one is Generating Sound and Organizing Noise, or what is it called? Organizing Time. This is a good book. This is how I learned Gen. Yeah, it's definitely something that it really builds from the basis. So if you do like ever want a really scaffolded way to get into Gen, for this class, obviously you could supplement with something like this. They really base it around ramps. So these like phasers, which we kind of looked at in the first couple sessions, all their processes are based around these phasers. And so it's kind of incredibly consistent. It also starts off with this like very low level that is kind of annoying that I did in the first class. But I recommend it. It comes also with a bunch of examples. There's a library, and I go back to that library very frequently. I use that quite a lot in Gen. Yeah. The other book is called Designing Sound. This is kind of an older hit by this person, Andy Farnell. This is also interesting because he's writing this around the time that people are using electronic music for video games. And so but like early video games. And so there's really this idea around a kind of economy of programming and like thinking they don't have so much memory, they don't have so much processing power, and so how do you kind of like think about that? And I think he kind of like grabs techniques from video games and takes them in to, most of that stuff is coded in pure data, but you'll see that actually there's so much kind of overlap between Gen and pure data. You can go one-to-one with some of that stuff, and in fact one of the examples I included this week is like literally I just went and like ported the pure data to Gen and it mostly worked. So
if they're really one-to-one, is there an advantage of one over the other?
Pure data is free. That's an advantage. I mean, it depends on the example, probably is what I would say. That would be my disclaimer. But again, Gen will give you the sample accuracy and pure data will not. And so that's why I don't want to say whether one is more advantageous than the other. I would think that Gen would be computationally more inexpensive. It would be cheaper. It would be more efficient, okay. I think. Okay. But somebody might call me on that. I'm not totally sure. But yeah, pass those around. Those are kind of like in addition to some of the other texts I mentioned in the first class. So yeah.
And then you talk about this being this book being written like when people were like first starting to like do like video game music. Were there like we're trying to like incorporate like electronic sounds into like video game music? Was there a time like before like video game consoles had like sound chips in them, so it would just be like I'm just trying to like because I know like a lot of like the earlier consoles like the Atari and NES and stuff like that. It was literally like they had like a couple of like they had like a couple of like really primitive oscillators in them that you had to like
just square wave synthesis.
Yeah.
Sorry, did you have more to say?
Yeah, I was just wondering like is like as far like referring to like is it referring to like how you would go about like doing the architecture for like those for those sound chips in like earlier video game consoles?
Precisely. Yeah,
gotcha. Okay.
That's right. So actually maybe this is I'll skip ahead to example 2.8 because it has nothing to do with the rest of the examples, which is exactly this. It is the sound of rain. Synthesized, right? Synthesized sound of rain. But if you crack this open, you'll see.
That's just the one I cracked open where I discovered you couldn't edit it, even though it all looked very max.
Before it looked editable.
Yeah.
Yes, right. So I saved this as rain, but you can, so you won't be able to Command E, but if you want to edit this, so right now it's read only, but you can double click in and change it. And so, you know, he like looks at the physics of rain and uses that to emulate this. You know, that's beyond me. I was just putting the numbers in, you know, but it is cool to sort of see that people are looking in that detail. So there would be something that you could do. You know, you can kind of futz with this if you want, and things are going to start to sound differently.
Which one is that? That's,
Okay, and so on.
PD, right?
Yes.
I've got a copy of that.
Okay, let's get into it. We have limited time. So today, today's really all about buffers. So does anyone want to tell us what a buffer is, or how we understand what a buffer is? It's like such a common word, but I feel like when we get started with this, when it's new, it's what the heck is that? What's a buffer?
It's kind of like your large intestine.
Okay, it's like an intestine. It's like some memory. Is that
A
right?
location in memory as opposed to a location on the device
That's
from
right.
which you can access data.
Right. Okay, that's right. So behind all this, there's some like memory, and I don't really know that much about it, but you could say, hey, like I need, as the programmer, some chunk of that, and I want to be able to put stuff in there, and then I want to be able to take stuff out. And I want to do that because I want to remember 4 numbers over the course of my entire program, for instance. Or I want to remember an entire bit of audio, right? Like a whole 2 seconds of audio. So this is extremely helpful. This is our very first, like baby's first buffer here. How does this work? Well, one thing is that now we have actually this max object called buffer tilde, and we give it a name called SRC, or you can call it whatever you want, but you need to remember the name because you have to refer back to it later. And then you can go and put different, we see that as we put different files in here, the contents of the buffer change. So really, if we zoom in on this buffer here, we see these numbers. What do these numbers correspond to? Any guesses?
Oh, those numbers.
That's seconds, probably.
It's probably milliseconds.
Or sorry, milliseconds. Yeah.
Exactly, but seconds. It's not samples, but it is seconds. But ultimately, a buffer is a series of samples, and a sample is like a number between 0 or -1 and 1, for example. So we have sort of our most simple way of accessing a buffer. And let's just see how this works here. I'm going to hit this. I'm going to send out a signal of 1 just to kind of... So if I send 1 in here, then I start to hear some sound. So let's see how exactly this works. Here comes in our signal. We're calling it speed. And then we have a counter. And we're adding 1 to the counter every time. And then here we're setting the limit for the counter. And the limit for the counter comes from this buffer operator. And the buffer operator has the same name as the buffer outside. So let's see, actually, just really quick here. I'll make an out 2. And we can just kind of see, exactly what's happening. So this is 153400. And again, this is the length of the sample that's in the buffer, SRC. That's the length of the sample, the number of samples. Samples are just these little things that we've been dealing with the whole time, these little slices of energy. If I go and I change my sample here, we're going to see that, is that the same one? this number changes. The length of that sample the length of the buffer in samples just changed, okay? So what we're essentially doing is we're adding 1 and moving through the buffer, and then when it gets to that limit, it resets. And that's what's coming out of here. So I could go and now I'm going to use this input 2. Now it's like we'll see what's coming out of this counter here. So we see it's going up, and then it resets, and then it resets. And what we could do is we could kind of see, well, I want to divide this. Let's divide this so it is a number between 0 and 1. So we'll take the length of the buffer in samples, and we'll use that as the divider. And now we're going to have basically something going between 0 and 1. And if we listen now to the sample, ooh, this one's so annoying. That one's annoying. This one's my most favorite.
Oh no, more beats.
Reset. And then a reset, right? So we're just, basically what we've done is just rebuild, like, we just rebuilt this thing that sometimes we use, right? Fine. So how did we do this? I guess there's one part I didn't explain. So this number comes out here, the number of samples, and it goes into this thing called peak. And what peak does is it peeks into the buffer. You give it a sample index, and it says, and then what it puts out is the sampled SRC or sampled buffer at whatever is coming in this inlet here. So this is how we sort of like make the sound. We play the sound back. Can I explain this again? Or are there any questions about this?
Seems pretty clever.
It's okay? Okay, cool. Because we're gonna keep going here. But this is the most basic kind of sample playback. It's good to know about this. Because what we could do is we could also say instead, play, but play at different speeds, or play backwards. So how does this work? It's very similar. One thing that I added, you notice I have this parameter that I can turn this on and off. So we haven't seen this checkbox yet. If you make this attribute and then you select it and hit Command or Control I, you can change the display mode. And so you could make it look like this, or you could make it look like checkbox. And checkbox will be 0 or 1. This is really handy. This is very handy.
Oh, so you're just using the inspector to change it.
Exactly, yeah. There might be a way to specify it inside Gen. I haven't figured that out yet, though.
That's easy.
So now we can play. But now what's happening? So now what we're doing is we're sending in a signal that isn't 1. Here we were just sending in 1, right? Just 0 or 1, right? But now we can send in like a bigger number or like a smaller number. So how does this work? So first of all, this is also an instance of us being able to use these parameters inside like a multiply. And so what this goes back to the checkbox. If the checkbox is unchecked, then whatever's coming in this inlet gets multiplied by 0. And that means we're not adding anything to counter. We're just stuck. But if it's at 1, then it gets multiplied by 1, and then we're moving ahead. Does this make sense? Mm-hmm. It's also kind of like a gate. It's just a nice utility. So same thing here. We're using buffer, and this outputs the number of samples. So we can set this count limit. And then we have peak, but we have something a little bit different. We have this bound mode here. And so we need bound mode if we are, let's actually see what like is coming out of, why are we using bound mode? Let's see what's coming out of counter, and this will hopefully make sense. So this seems fine, but what if we have a negative? So usually like our buffer is only between 0 and like whatever 100,000. There's like 100,000 samples in there, right? So can we access a negative buffer index? No, we can't. But what this does is it basically is like if this number goes negative, it wraps back around to the end and keeps reading through it. So this is also a very handy utility for a number of things actually. So this means, okay, well now we're going to peek into the buffer, but if we give it a number that's outside the bounds of that buffer, it's going to do something with it. It's not just going to break, essentially. And then interpolate, like the other thing too to keep track of is like now we're adding numbers which are, you know, they're not discrete. They're not integers. They're also floating points. And when we think about an index, like we have basically, what is a buffer again? It's like 100,000 values that are different intensities. But we look at those in terms of their index, right? We'll say, show me sample 1, show me sample 2, show me sample 3. What if we give it 3.5? What does it do, right? What it does now with interpolation mode is it says, well, just like give me the average, right? Or like show me, if it's 3.7, it's going to give you a number that's a little closer to what is stored at 4, but it's never going to like, it also won't break, if that makes sense. Yes?
Is this how like all digital like speed up slow down processing works?
I can't say that with any authority, but I would think so. Something
Okay.
like that. Yeah.
I think for the longest time I thought that it was like literally like slowing down and speeding up the sample rate.
So nothing it wouldn't be anything at the hardware level, but there is also, I mean, I should mention too that like this would be done more complexly with an FFT process.
Okay.
Which is a whole other it's a whole other thing.
Yeah, with like
Different class.
Exactly. Yes, that's right. Exactly. Exactly.
Do time stretching with that.
Exactly. Thank you. Yeah. So what exactly? So what happens when we change the speed, right? Let's use if we use a musical example. It changes the pitch. If you wanted to maintain the pitch, you could do that, but you need essentially a different process to do that. Something called an FFT, where you're like, well, whatever. We're behind schedule. There is something called an FFT. There's probably a whole class to be done on that, but
You did it with granular synthesis too, couldn't you?
you could do the math on it. Yeah, that's true. You could do the math on it. That's right. Wait, no, I don't know. Yeah, you could do it with granular
It's kind of
synthesis.
not
Yeah.
trivial to do that, but
With granular synthesis?
yeah, it's a lot of work.
Yeah.
you can space like
This
the
is true.
grains out. I've done that. It gets some, but so there's artifacts for sure.
Yeah,
But you
that's-
space the grains out to go slower, right, and
Yeah.
speed them up
That
and
makes
drop
sense.
and drop some to
This,
go
this is a
fast.
lot smoother.
Yeah.
I'm assuming
Yeah.
there's different arguments for the wrap. Oh, excuse me, interp rather.
Yeah, maybe.
Yeah, you
Perhaps.
can have cubic,
Uh-huh.
yeah. I checked it out as part of my homework.
Oh, nice. Cool. Yeah, I guess that totally makes sense. You can. So what we're saying is that if you wanted to stretch this out, but maintain the pitch, you could basically stretch this out, but then like you're looking at basically little windows of samples that then you kind of like you make that sample, you play it longer, I suppose, or you duplicate it in some
It
ways.
has to do with how far forward and backward it looks. Right? If you interpolate linear, it's just 2 samples. If you're using a quadratic function, it's going to be 4. If it's cubic, I think it's either 6 or 8. I'm not sure, but you're looking at more samples and designing a curve from the previous values.
Yeah, exactly. It's curve fit.
Yeah, totally. That's a whole other world. I love it. We're gonna keep rocking. So we might also want to do something where how to wobble. So what is a wobble? Like we want to think about maybe this would be varying pitch, or actually like getting a kind of variation in pitch that sounds maybe a little bit like vibrato. So just to kind of go back here, let's hear it without. What is it? 1.04. We hear this is a straight tone. It's a vibraphone. There's ways to do vibrato, but usually you don't hear vibraphone with vibrato. But what we can do is we can subtly modulate the playback speed. And we can make this more dramatic by increasing the depth. Wow, hold on. Right, you get seasick. Or you want something a little more tempered. This is just like a nice kind of effect, like it gives a little bit of richness. And like, especially if you're using this, like if you're using a sound again and again, in a way, this is going to kind of bring a little bit of warmth to it. It's going to sound a little more organic, a little less deterministic. Like, you just hit playback on something. So how does this work? This is basically, it's frequency modulation. We have a sine tone that has a hertz, and that's multiplied. We multiply the amplitude by this depth here, and we're just adding that to the value that gets added to the counter. That's it. That's really it. And then everything else here is the same. But sometimes, so what's interesting about this, just to listen to this, like, the sample has its own rhythm, right? And if we listen, we can kind of hear the wobble go independently of the onset of the vibraphone, which could be interesting. Maybe you want that effect. That's also not like how musicians perform vibrato. They'll like do an onset and then start vibrato. So maybe what you want to do instead is think about resetting your vibrato. It's a very slight difference. So now every time the vibrato will be this, actually it will sound the same in some ways. You could have this randomized every time. Okay, how does this work? This is like something where the cycle object or the cycle operator doesn't let you reset, which is very strange. So you basically build like a sine function by yourself. And this is basically what stands in, all this stands in for cycle, right? All this is cycle essentially. But we can reset it every time the counter gets to the max. So then that sine tone is going to go back to wherever it started. This is also like a very kind of modular synthesis kind of way of thinking about things. It's this could be resetting this wobble. It could be resetting like a filter opening and closing. It could be resetting an envelope. It could be resetting a lot of different processes here. So this is actually kind of a detour. We're not really talking about buffers, but well, we kind of are, because now we're thinking about the buffer structuring when that thing resets, right? Again, it could be like a filter opening, like an acid filter or something like that, or like particular bass sounds have that as well. Okay.
So this is all real FM, right? If you wanted to do phase modulation, you have to do a little more work.
Correct. Yeah, correct. Yeah. Other questions? Cool. Let's rock. No. Okay, so where we're kind of going today, I think, where we're going is granular synthesis, and then we're going to show a few other things. So as has kind of already been alluded to, granular synthesis is going to be like, we have that buffer, but maybe we don't want to play it from start to finish, right? Maybe we want to think about that as like, you know, a bag of candy, and we want to be able to go in and grab different bags of different kinds of candy from there. This is a good metaphor. It's very good. It makes a lot of sense. Everybody's on board with it. It's not confusing anybody. So let's see here what we have. In this case, we might have to... Oh, this is not even playing. Hold on. So what I can do, let's actually use this drum loop. It's going to be better. So I stutter this, right? What's actually happening? So of course we remember I send a click in, which is sending a momentary pulse of 1. Actually, same thing. I preserved this entire this is the wobble. This is what we had before. This stuff is not new. This is what's new. This is what's new. Whoa, I made this on my big screen. This is what's new. Click to jump. So we basically, when we click, we sample a noise value. And we're using this sort of jitter, what I'm calling a jitter. Wait, what am I doing? What is this? Do we need this? I don't think we need that. Jitter is then, oh, okay, great. I see what's happening here. So we're getting the length of the buffer in samples, and then we're multiplying that by some number between 0 and 1. So let's imagine the buffer is 1,000 samples long. It's not. But if I say 0.5, then like I can sort of think about this is going to offset like maximum halfway through the sample. So let's see if we can hear that. If I make this really small, we're going to get little jumps. Kind of sounds like the drummer's drunk or something, right? But if I make this really large, basically it's going anywhere, like jumping anywhere forward in the entire sample. Or if we want to say, okay, you can jump up to 50%. Okay, this is not musically interesting. Well, maybe you could make it musically interesting. I have not made it musically interesting, but this is what's happening here. So all we're doing is we still have this wrap mode on, and we're just arbitrarily adding to whatever count. So remember, we're peeking into the buffer to see what to play back, and then all of a sudden, in comes the number 500, and then we jump ahead that many number of samples, right? So far, so good? Okay, cool. So we can start to mess with stuff. We also may want to say, well, this is similar. When I jump, I want to use one of those envelopes, right? So I want to basically jump and then get a like womp or something like that. So this is from the 1.6 example using slide here. So this is very similar to what we just heard, except that, oh, hold on. We're enveloping it. If I use the vibes, this can be helpful, right? So I can, so it's like you're kind of gating the sound when you're sampling it, right? So this is also kind of the basics of granular synthesis. We kind of like something like that. We good? Okay, cool. Okay, and then this is actually just a way to automate this, right? So this is kind of a typical structure here for making random time intervals. So this is in Max, obviously, but so it's a little bit of a detour. But when this metro bangs, we're going to also generate a random value, and that's going to change the interval of the metronome, and so that's why this looks irregular here. And there's something called start and stop, which I forget what it does, so I'm just going to listen to it and see. What was I trying to do here? Oh, speed. What does start do? Maybe this is one that sounds better with this.
Determining where in the buffer you begin.
Yeah.
Oh,
Yeah,
yeah,
looks like
thank
The
you.
parameter of start then being added to what's emptying out of the counter, and then clipped instead of wrapped.
Thank you. Yeah, so what we're doing is we're basically saying, I don't want to hear the first part of the sample, right? I want to hear, now I'm hearing the whole sample, but maybe I just want the last 75% or the last 25%. And basically then it's only going to grab from there, right? So it's a way of sort of shortening it's a way of limiting the scope of where we're grabbing samples from.
Could you go up a little bit? Scroll up.
Mm-hmm.
Yeah, what's with the TBB?
So this is just a way of generating these random pulses here. So metro goes, it gets a new number here that changes the interval of our metronome.
I forget what TBB you're generating a trigger at 2 bangs.
These are bangs, yeah, exactly.
So
So this is a trigger. So this is definitely a max structure. So and actually we don't really even need this BB, but like bang comes out here and goes there, and then another bang comes out here and goes there, essentially. But actually we could just hook this up to metro. I guess I'm just used to seeing it like this.
do you even need TBB?
That's what I'm saying. I don't think you need it. But I like it. It makes me feel safe. I don't know. It's nice to have one bang coming out here, the other bang coming out there. I don't know. We don't really need it though. Okay, so we're building towards something here. So I'm going to, I think, save this because I fixed something. But let's look at this. I think this is actually where things get a little bit more interesting. So far we've been looking at like, what if I grab a sample, and well, actually this is similar in some ways. Let's see how it's similar. So now this is repeating, and how does this work? So if I open this up, it's actually very simple. We're like actually much more simple, right? We like that. So in comes our trigger, that's our pulse. And then it goes into the send, and then just to kind of, for my eyes, I send this into the send, and then everywhere that it says receive, that also gets, I guess it's just these two places. Anyway, yeah, that's also kind of OCD, but anyway, here comes a trigger, and it looks like, what are we doing here? Well, we're going to multiply this phaser. So this phaser is coming through here, and it is looking at, basically looking at different lengths of samples, right? So let's go back and see. Let's see if we can hear like different lengths. So this could be up to 1. And then offset here is also going to be what we were just talking about, start and stop, essentially. So right now the offset is between 0 and 1. So we're grabbing anywhere in this sample here. But if I say 0.5 and 0.6, we're really just like right here, something like that. Okay. So now, right now we can't change. There's a rhythm embedded here, right? And the rhythm is embedded by this phaser. So what we want to do is be able to change that, because this might be interesting. We might want to like subdivide this, or we might want to do some cool metric modulations or something if we want to do go the footstep route, right? Or footwork route. So now what's happening is that every time we're basically setting a limit and saying, okay, we hear the rhythm again, but every time we get to a certain limit, grab a new sort of sample to play back. So I could say the limit is 10, we're going to hear a sequence of 10 of these. Or 2. But now I can also change the frequency or the hertz. I could change the maximum length. And maybe I want the limit to be higher.
So the frequency is the playback speed?
The frequency is the playback speed.
Okay.
Exactly.
But the frequency also corresponds to the frequency of the phaser.
Yeah, because the phaser is basically like, okay, so great question. So what is this over here? This is a phaser. And what it's doing is every time we hit go, we get a new start, we get a new stop. And the phaser phases through that, basically. So if we increase the phaser, now we go through the sample more quickly. We're not doing any kind of pitch shifting, obviously, right? When it goes faster, the tone gets faster. But you can start to do some like cool effects here, right?
Oh wait, that is shifting the pitch by changing the pitch.
This is shifting the pitch. Sorry, you're right. We're shifting the pitch, we're not pitch locking. Yeah. But you can get some cool effects this way. Right, like here you go. This is something.
Wait, Ultron looks shifting.
Totally. And you can replace this with other samples. Now it's going to sound very different. Or maybe not. Right. So, you know, here's your space opera opening or whatever. Cool, right? Okay, so this is cool. This is the one I had the most fun with this week, which is what I want to happen is for the limit and the frequency to automatically shift when it gets to the limit, right? So basically, there's a max number of limit and a minimum number to limit. But right now, this is like there's a very musical rhythm to this. It's very fast, but like, or maybe even if we do like, right? It's periodic. This is different. We get a play button here too. So I've also visualized this down here, which is maybe helpful. So this is like, you could kind of parameterize this in a way to generate sonic textures for you. That would be, they're chaotic, but so now this is the same region of the sample that was playing before, but it's because the pitch or the frequency is different, it sounds quite different. But this gets really fun with like these drum loops. So I could also like dial this stuff back a bit. But this is very fun. You know what you could also do is we could make this negative. Never mind. Actually, that's complicated. But if I parameterize this, I can get very different tones from it, which I like because now it feels a little bit more like an instrument.
I'm sorry, what's the max limit and min limit?
So you hear this sample repeating.
Yeah.
The limit is the number of times that it repeats. The max means that every time it finishes that phrase, it generates a new limit, and max limit is the max sort of number of repetitions you can have, if that makes sense. So it'd also be possible here to like quantize the hertz in a way where you could be having like subdivisions, for example. So it's like, so right now the speed of this is totally chaotic, right? It could be like 0.73, it could be 0.21 or something like that, but it could be half speed, full speed, 1.5 speed, and so on, and they would also have a musical relationship to each other, a rhythmic musical relationship, which is structured in meter, is a metrical relationship. Is what I'm talking about. I can also change the length, and maybe even change the offset. And maybe change the hertz too, like maybe 0.75, right? And I can make the max limit 20 like this. I can make the min limit, let's do something like this. Make the min limit 10, or we can make max limit 10. What about 8? Then you're gonna have also this very musical kind of like, you have a beat and then it's gonna shift every 8 pulses, for example. Or I say maybe the max hertz is the same as the min hertz. And so we have to wait for it to cycle around. Let's make this 1 actually. And so it's going to feel a little shifty, but it's going to feel a little bit like kind of a beat playback. Also kind of like drunk drummer effect. Could be interesting. But I really like to play, of course, with this, like the glitchier effects that are high speed, I think are really cool. And with different, just to sort of go back to that, and then we can either keep going or we can look inside depending on what people want to do. With different sounds. You get very different tonalities, right? Just based on the sample. So you can bring in different samples here, and really like your choice of sample is going to really like enlarge the kinds of tonalities you can make with this effect here, right? Because really we're like looking at these little micro textural kind of details and exemplifying them by repeating them and playing them at different speeds and so on. How are we feeling? We have about 10 minutes. I can go into this here, or we can keep going with examples. There's like, I think the granular example and then some MIDI stuff if people are interested in that. Should we keep going?
Sure.
Yeah? Okay. So I think we have two big topics. So we can do either granular synthesis or we can look at polyphony.
I like granular.
Yeah.
Granular gang. Okay, cool. So this is one way to do granular. This is taken from Max's examples, but I've like clarified them. There are actually some mistakes I fixed, you know. That's right, yeah. Thank you. There are other ways to do this, but let's listen. So this is show, I guess. And we'll see, we talked about in the envelope example, we talked about these windows. This is called is it called a Hanning window? I can change this, and it's going to slightly affect the character of the sound because it's being windowed differently. You might be able to hear that. Maybe. Okay. So if we open this up, okay, yeah, this is also why this is kind of a little bit of a landmine. They've basically decided to deal with polyphony inside of the Gen code box. So we're hearing not just one tone, but a whole like cluster of tones being played back at the same time. And they're doing that here using a little bit of code in the code box. If we see here, for example,
Anybody wants to see the code?
thank you, Paul.
Thank you.
There's a for loop in here, which is basically repeating this process multiple times. So if you know sort of text-based code, you can look at this. However, this is also like a ready-to-use example. You also don't need to know how to use it, how this works. You just need to know how to use it.
Anybody want a better readable copy?
So what we're inputting here is actually a range. These are all ranges. So we can hear this is the speed of the playback. And now they all sound consonant because they're all playing back at the same speed. But if I give a range, now all of a sudden it doesn't sound consonant, right? Negative values will play in reverse.
So with one particular value, we'd be sweeping through the buffer, but at whatever the rate was of that single value.
Yes. Yeah, that's right. So this would be like we had the phaser last time that was playing through the glitch, those little glitches. Basically, it's the speed of that phaser, but imagine there are like 29 of them, for example. So density 2 is going to change things. Or wait.
How many grains we're getting at once?
I think actually maybe density is the... Where's length? I think actually maybe the number of grains is hard-coded. Where's len? Len is... Oh no, it is density. It should correspond to density. Yeah, okay. The frequency going to hear too much. And then where is like also the range of playback. So we're going to get now like more varied sort of sounds, which are being randomized. And then how offset are each one of these grains going to be from one another? So this is one way to do granular. I want to show you really quick one of these examples from this Generating Sound and Organizing Time book. So these are, like I said, very good examples. Great. So this is coded up by one of the two of them, I think Graham Wakefield.
Oh, is this a library from GSOT?
Exactly, yeah. It's good. I recommend it. And Max crashed, so that's cool.
It does.
But we're going to see something very interesting here, which would be a nice transition into talking about polyphony if we have time, but we can start with it next week. No. So this is this looks a little bit similar, right? Oh, funny. Hold on a second. It sounds similar. So now we're able to actually like sample different portions of this. But if we look inside, so one thing we'll see here too, the voice count is variable. The voice count is the number of grains at once. But if we look inside, we're gonna get a little headache.
Oh, hello. Is this like what you were advising us against doing?
Unless in this situation. Yeah, exactly. So unless you're doing exactly this. So what's happening here? Each one of these is getting basically a message. Well, no, sorry. The first one of these is getting a message and says, hey, play this. And inside of here is a little switch, like a light switch. And the grain, this little guy here, when it's busy playing some sound, it flips that switch on. And when it's done, it flips that switch off. So a message comes in here and it says, play this sound, but the switch is flipped on. So what does it do? It passes that message on to the next buddy. And then is that buddy busy? Is that switch on or off? If it's off, play the sound. If it's not, or if it is busy, it passes it on. Which is why all of these are chained together like this. So this is also a way to get polyphony. Now, there are many different ways to do this. We'll look at the poly object next time.
Would this be a bit strange to do in poly? I mean, this is, you can look at this and it kind of makes more sense.
It makes sense visually. Poly is famously hard to get. But the reason to do this way, in my mind, is I'm thinking that actually Graham Wakefield wanted to put this on a daisy. He wanted to put this on some hardware where you don't have recourse to poly object, right? And you can't use MC. And so he's thinking, how do I do this entire process inside of Gen? And this is the answer to that. Actually, that's my guess. I have no proof of that, but
Could you blow
it's
it
my
up a little-
headcanon.
Could you blow it up a little bit? It's very difficult for me to see.
Sure. So yeah, it sends out audio left and right, and then here is that busy status, which if we look inside, this is actually pretty simple. This is just one of these guys, and this is where it gets its windowing function from. This is like the Hanning window, where it like, something like that, like sort of brings the sound in and out. This is where this is the same thing we saw before, right? We're peeking and looking at the buffer. Where do we go and look from? Basically we get the speed here, the offset, panning as well. from left to right is randomized in this particular way. But the busy comes from right here, right? And this is where it's basically keeping track of whether it's busy or not. Now, we don't have time to totally go into that, but it is possible to do this inside Gen. Yeah.
Where's this patch located?
This patch I haven't put in the thing because it's in this generating sound and organizing time, but library. But maybe I can just give that. Or wait, is it in the Max Package Manager? Maybe you can just download it.
You can download the whole thing from that book and put it in your packages.
They have if you look in the book too, they have the address in there.
Oh, so you do have to go to the address though.
Yeah, I forgot what the URL is. Really simple.
I thought I saw that you posted the link to do that somewhere.
I may have. Yeah. I probably shouldn't have. You should buy the book. You can buy the Kindle version. Kindle version's good. It's $20.
Oh, okay. So this
$20.
comes with the generating sound book.
It does, yeah. You can download on it. I mean, you can also just
like
look and download it yourself.
Okay.
That's totally fine. But yeah, it is in there. If there's like a strong, I think probably I'll keep it out of the package just out of respect for the, or I'll keep it out of my examples just for respect for the code creators. But it's very easy to find.
Okay.
And I'm happy to share it if people want it. But on that note, we should probably adjourn. I think for next week, I think what might be fun, I can show more stuff. I'll have more stuff to show. However, if people want, before Tuesday, I would say send me some requests. Because I think what might be helpful to do is to build something up from scratch together. Because right now I've just shown stuff and you've taken it in and it's like, whoa, but actually thinking through how to sort of structure things as a group, I think would be very useful. It will also be very humbling for me because I won't know how to do something. And you can enjoy that, I guess. But yeah, so send me an email or send me something on the Discord. Let's make a drum machine. Let's do... let's make an effect. Let's make delay. We haven't talked about delay. There's all kinds of things we can explore. It would be great to get like a bunch of requests, and then I can maybe think about the ones that would be most instructive and easy to tackle in class. So that's your homework, is to send me homework, basically.
I think I raised this as a request already. I'd really like to know what's going on in this code box for that. That one example, 2.5.
Oh, for the granular thing?
Yeah.
Yeah, me too.
I can kind of get the gist of a lot of it, but some of the stuff like change, what is change?
Well, they've named the variables in a very cryptic way also.
They
What is
have.
IoT?
Yeah, it's
What is
Internet of
IoT?
Things?
Yeah. We can try, I think I might be able to look at that. I think I don't want to spend too much class time on it because the code box is a little alienating, I think. And so I kind of like to treat it as a black box, but I can sort of step through it really quick right now as people are packing up, but I don't want to keep anybody either. If that's fair.
Okay.
Okay. Where is it? Oh yeah, it's here. So these values come in. Oh my God, am I going to do this? I'm so tired.
It's kind of disorderly that way. I can send you my formatted code and you could try
Okay.
And it's right here, yeah.
That might be helpful.
Yeah.
I mean, I did go through, one of the things that I did do to this example is I went through and I commented all the lines, which they were not commented in the original. So yeah, you have like frequency coming in. You know what? I think let's do this next time because I think I'll probably black out while I do that. I'm feeling like I'm losing time. Yeah, that's right. Let me look at this. Let me see. I need to think about whether we want to, because the other thing is like a very particular kind of granular synthesis called overlap add, which is like making it so that there are these overlaps between the grains in this particular way. So yeah, let me think about it. Maybe we can go deep into. Okay, how about this? Send me a request to build granular synthesis from scratch, and we'll do it in reverse. I think that might be the way to do it, if that makes sense.
Okay.
Yeah. Okay.
And there must be a list of all the reserved words or whatever you want to call it for CodeBox, right?
It's it's the operators in Gen.
Exactly.
Right. It's just X.
It's
Really?
exactly. It's the operators themselves. Yeah, except for
Yeah.
the if statements and like for loops and declaring these
Right.
kind of variables, they look a little different. But also like sidebar literally. If you hit this code box here, it reveals that this is actually the sort of like pseudo C++ of this whole gen operator here.
How'd you get that?
If you hit code box here. So this, if you're interested in code box, this is a really nice way to start, is that you can just say, because I think that really is its own course. But if I open this, I see, oh, there's something called add 1, and it's equal to plus 1 in 1 plus in 2. Oh, okay, that's these, and this is add 1, and then wait, out 1 is equal to add 1. Oh, okay. And so what you can do then is you can start to change this, and you can say multiply this by noise or something like this.
Whoa.
And then this should, why are you not doing it? This will refactor on the fly.
Whoa.
Yeah, that's crazy.
It's actually kind of crazy.
It's pretty neat.
It's pretty cool. It's pretty cool. But also, that's why we show this week 3,
I'd also
because you get like
suggest
What?
this is week 3
You mean
material.
this whole time I could just be writing text?
Yeah, that's right. I know.
Roundabout way I learned to just be writing pseudo C++.
I know. That's right.
But what's nice is then you can sort of escape from this proprietary universe
It's true.
of Max and have
Yeah.
code that you save. I really like the feature for that reason.
It's portable. Yeah, exactly. All right, folks. Thank you very much. Thanks for the interest. We'll see you around. We'll see you next week.
See you next week.
Cool. Good night.